Hello, everybody. We are going to be discussing today the updates to the AERMOD modeling system recently posted by the US EPA's Air Quality Modeling Group. First, allow me to introduce myself. My name is Michael Hammer. I am a senior product specialist with Lakes Environmental Software and a certified consulting meteorologist. For those of you not as familiar with Lake software, in addition to our commercial software products such as AirMod View, CalPuff View, IRAP HView, and more, those dealing with air dispersion modeling studies, we also provide IT solutions like our powerful and complete air quality management and information system. It's a fully cloud-based system that incorporates a number of different modules from emissions calculations to monitoring, modeling, forecasting, reporting, compliance, and more. It is a fully customizable system. If you have any interest in those type of large package solutions, we'd love to hear from you. And of course, we also provide training at regular times throughout the year. Our online AirMod and CalPuff courses have been very successful in lieu of the pandemic. We certainly do miss seeing you all guys in person, but we're glad that we're able to reach people in an online way to continue providing our high quality training solutions. But you're all here to hear about AERMOD, so let's get right to it. The AERMOD modeling system, as the US EPA's preferred air quality model for near-field impacts within 50 kilometers from a release, as it is preferred and designated as the preferred model by the Guideline on Air Quality Models, also referred to as Appendix W to the Code of Federal Regulations Part 51. The modeling system is developed and published by the US EPA's Air Quality Modeling Group. I'll have a link to their website here in just a second. And on that website is where they publish regular updates to both the modeling system as well as other important announcements, things like new guidance memorandum, decisions made by Model Clearinghouse, and other important notices that are of interest to the modeling community. Now, the AERMOD modeling system is made up of the AERMOD air dispersion model component, but it also has a series of pre-processors to help format data for use within this system. That includes meteorological data processed through Airmet and its component preprocessors, air surface for analyzing land use, and Airminute in the United States for preprocessing automated surface data, wind data. So Airmet's meteorological data helps supply the planetary boundary layer information to the AERMOD model. We rely on the preprocessor AirMap for analyzing terrain elevations, as AERMOD is a complex terrain model. And we also utilize BPIP Prime for assessing building characteristics and their influences on plume rise from point sources. So all of these components work together as part of the AERMOD modeling system, and each component can be updated at pretty much any time. Now, on May 11th, the US EPA's Air Quality Modeling Group published updated executables and code for the following system executables: AirMod, Airmet, and AirScreen. The new versions were dated 21/1/12, continuing the reign of palindromic version numbers. These 5-digit numbers refer to the 2-digit year and 3-digit Julian day on which the model was compiled for publishing. Now, the EPA's website, the Support Center for Regulatory Atmospheric Modeling, is epa.gov/SCRAM. And as I said, this is the website where they publish important notifications about the modeling system. Now, in terms of the changes of the AERMOD modeling system, there is a stratified list that is prepared. Each update to the modeling system that occurs, or each modeling component, gets a model change bulletin published. And the model change bulletin will go through 3 primary changes to the executable. The first are bug fixes. So when there are coding issues, when there are mistakes found, when there are issues that need to be addressed, corrections and fixes are applied, and those are noted in the model change bulletin. The next set of updates are model formulation updates. This is where we start to see new model features applied, Existing options can have new components applied to them, and also an update to the algorithms within the model itself. Often when we see these formulation updates, what we will see are many new testing features, new model options that are applied for testing and evaluation purposes, and these could go all the way up to complete changes to the regulatory model formulation itself. There will also be enhancements listed in the model change bulletin, and these are just updates to existing versions. They may consist of new switches, new options that can be applied to those, but it doesn't fundamentally change the formulation of the model itself. It just takes an existing routine and expands upon it or modifies it in some way. So let's take a look first at Airmet. And the Airmet changes for 21.1.12 were all bug fixes. This is literally a case where you can download the Airmet executable, you can rerun it, there's no changes needed to be made to the input file, to your input data. All of that can remain the same. Your existing Airmet projects will run straight away in the new Airmet executable. Some of these bug fixes include minor data reporting updates, which don't affect the output of the model, but simply consolidate some of the existing code to work a little better. Some routines have improved reading and handling of the TD3505 or Integrated Surface Hourly data files. This is a common surface pathway input data file that covers locations all around the world and for time periods dating back many decades all the way up to within recent hours. So it's very commonly used these days, the TD3505 file, and those can be read a little more easily now in Airmet. There's some updated heat flux handling for missing hours as well as the transition hours between convective or daytime boundary layer and the nighttime or mechanical boundary layer. And then just general code optimization applied throughout the Airmet model. So like I said, no major changes to Airmet, just some updates, bug fixes, things that can be easily applied to existing projects without even you knowing that there's really anything going on internally. You simply run the new Airmet model, you get the updated surface and profile files, and pass those along to AERMOD. Now in AERMOD, first let's go over some of the bug fixes. There was an issue identified in a previous release of AERMOD involving background units. So background concentrations can be applied to the AERMOD model. This has been a part of the model going back for many years. There was an issue with the background units. There was a selection that could be made that identified the background units as micrograms per cubic meter, as parts per million, or parts per billion. And a bug was identified in which the conversion between parts per billion and parts per million into micrograms per cubic meter was not occurring properly for all pollutants. And the intended use of the background units was that only a subset of pollutants were intended to use ppb and ppm. So in this update of AERMOD 21.1.12, there is a conversion issue for NO2 that has been corrected, and it now restricts the model to only allow parts per billion and parts per million units of background concentrations for NO2, SO2, and CO only. All other pollutant IDs must use micrograms per cubic meter as the unit for their background data. So if you're downloading your background data in a different unit, you'll want to make sure to convert that first before inputting that to AERMOD. There have been some changes made to the buoyant line source routines. The ability to model with flagpole receptor heights has been added back in for buoyant line sources. And a check has been applied so that the alignment of buoyant lines makes sure that for a single group of lines, they are parallel to one another. A correction was applied for RLine with variable emission rates, the emis fact keyword from the source pathway, and then other internal corrections. Now we get to some of the more deep changes to the model. Now when we discuss model formulation changes, as I said before, we're talking about changes to the model algorithms themselves. This could involve a new source type. In the 19191 update to AERMOD, for example, there were the brand new RLine and RLine XT source types added. So these additions fundamentally change the way AERMOD is conducting its calculations. Now for the 21112 release, regulatory default mode remains unchanged. There are no model formulation updates per the EPA's model change bulletin to regulatory mode. This means for many of you, when you reprocess your MET data with 21112 AERMET and you rerun AERMOD for 21112 in regulatory default mode, you may not see any changes at all to your concentrations. You'll see minor updates like the version number noted in the output files, but you won't see anything major applied to those. The beta options also remain unchanged. Currently, the only beta option remains the RLine source type. So all 21112 formulation changes remain alpha options. For those of you not familiar with the alpha beta default designation, I borrowed this image from one of the EPA's recent presentations discussing the hierarchy of model options within AERMOD. So in regulatory default mode, we have the set of options that are applied and assumed to be used in regulatory exercises. You're submitting your model run to get a permit, for example, you're probably going to be running in regulatory default mode. Then there are non-default options that, if used in a regulatory context, typically require approval. And these non-default options have been stratified into alpha and beta options. Beta options are those that have undergone some significant vetting process. For example, scientific peer review. They have multiple databases available for their evaluation and testing. So they're very close to becoming regulatory options. They've gone through well-documented review already. They are available for testing such that eventually they could be promulgated as a regulatory option. Then we have the alpha options, and the alpha options have not undergone that same level of review as a beta. So in order for an alpha option to someday graduate to regulatory status, if at all, it would need to first undergo that scientific peer review, for example, or have more testing databases made available. And this image here is just a depiction of one possible way that the options could move through the development cycle. There's nothing to say that an alpha option couldn't become a regulatory option straight away and bypass beta. It would just need to undergo thorough review and testing. So these non-default alpha and beta options are there so that the stakeholder community can evaluate them for themselves. Maybe you've done some field tests on your own, and you can validate those tests in the model using these options and then provide additional feedback to EPA on how these options are implemented, potential changes that need to be made, and so on. So all of the formulation updates in 21112 are alpha options available for testing and evaluation, but really need to undergo some significant review before they could be considered for regulatory use at some point in the future. The first major updates to these formulation changes relate to NO2, nitrogen dioxide calculations. There are two new alpha options applied, and these are non-default options, as the alpha flag implies. The first is the travel time reaction method, which takes a look at the speed of the NO and O3 reactions in the ambient environment. As this graph shows from one of the EPA's modeling white papers, the conversion rate of NO to NO2 can be undergone at shorter time periods as more ozone is available for reaction. With lower ozone concentrations in the ambient environment, we see a slower reaction time rate and faster times for higher levels of ozone. So this option is attempting to consider the speed of that reaction. It calculates travel time for each source type, stability condition, and plume dispersion type internally. It has similar data requirements to the existing Tier 3 screening options, ozone limiting method and plume volume molar ratio method. So for TTRM, you would have to supply an ambient equilibrium ratio as well as a default in-stack ratio. The next new NO2 reaction method is the generic reaction set method, or GRSM. It's an alpha option, and it was developed by CERC, the Cambridge Environmental Research Consultants in the United Kingdom. This is the group responsible for the ADMS air dispersion model, to those of you who are familiar with that. The reaction coefficients within GRSM were developed by CSIRO from Australia. So what GRSM does is assumes instantaneous mixing of the background and also supplies an avenue in AERMOD for the inclusion of background NOx in addition to the required background ozone concentrations that we are already familiar with through the Tier 3 methods as well as TTRM. So you'll supply 2 levels of background to go with the NO2 calculations. Then using that data, the reactions are modeled out to calculate the NO2 concentrations. Some formulation updates were applied to the RLine XT source. Recall RLine XT was first introduced in the 19191 model version as an alpha option, where it remains to this day. It's still an alpha option. And RLine XT was expanded to now include a second road barrier. The RLine XT source type allows for road depressions and road barriers, but the initial implementation just had a single barrier algorithm. That single barrier algorithm has also been updated in 21.112, but now in addition to this single barrier, you can also apply a second on the other side of the roadway. So you can have an enclosed roadway with double barriers. Other alpha formulation changes include the long gestating low wind options, the option to specify a minimum sigma W turbulence value can now be included, and the time scale for the random dispersion, which defaults to a single day, 24 hours, can now be modified to anywhere down to a half hour up to 2 days for that random dispersion or TRAN figure. The alpha downwash options have also been updated. Some of you may recall that in 19191 we had the addition of the EPA's ORD alpha downwash options, which included a new BPIP prime draft executable. And then the Air and Waste Management Association also contributed to some development of alpha downwash options, and it is those AWMA options that have been expanded in this release. The 2 new AWMA alpha downwash options include AWMA entrain, which changes the beta entrainment coefficient, and AWMA U-Turb HX. It follows up on a other option that was already included as part of this, the AWMA U-Turb, which modified enhanced turbulence and wind speed calculations. This HX option now uses a downwind plume rise method with it. And then we get to the additional enhancements, so modifications made to the AERMOD model, not necessarily affecting the formulation of the model, but new features and functions that are available. Starting with the meteorology pathway, the user now has the ability to set any turbulence values found in the PFL metadata file to missing. So if you happen to be using a metadata set that includes those turbulence data values, sigma theta, standard deviation of the wind direction, sigma W, standard deviation of the wind speed, then you can tell AERMOD to ignore those values, and you can do so for different groupings of hours. You can do this for all hours in the MET file, for the stable only hours and convective only hours. Another enhancement is the ability to group buoyant line sources. So in the prior implementation of the buoy line source, you would have a set of buoyant lines applied, and then the average properties of those lines had to be the same throughout the project. Now you can separate the properties into different groups. So I could have a set of buoyant lines in one part of my domain, maybe that run west to east and have their own set of properties, but I could then have a secondary group of buoyant lines running north to south with their own set of properties. The deposition abilities of the model have been expanded a bit in that some default deposition parameters are now included for special pollutants. So if you're running gaseous deposition, you have elemental and divalent mercury will have some default parameters, dioxin in the form of TCDD, PAH as BAP, sulfur dioxide, and nitrogen dioxide. All you would need to do for these parameters is when you input them, such as the diffusivity, Henry's law constant, etc., you would input values of 0, and then using the specified pollutant ID, the model can insert the default parameters. Method 2 particle deposition now also has fine mass fraction and geometric mass mean diameters applied for arsenic, cadmium, lead, mercury, and PAH in the form of the pollutant IDs identified here. So that helps reduce the burden a little bit of having to find those parameters on your own. One additional enhancement that I'm very happy with is the removal of a very outdated warning message, the wake flag warning, which would give a warning if the height of a stack in a building exceeded the EPA formula height or GEP height. There would be a warning applied if downwash parameters were still calculated for that particular stack. That warning has been removed. This is something that's been a part of the modeling system for 10 years now. And so that warning isn't nearly as relevant as it once was. So that's a quick overview of the changes that have been applied to the AERMOD modeling system in this go-round. And we are in the process of incorporating these updates into our AERMOD View software package, which will be released as version 10.0. We anticipate making that release in the coming weeks. This will include support for the 21.112 models and support all the new features, including GRSM, TTRM, RLine XT, and all the other options that I've specified here today. A new parallelized AERMOD MPI executable will also be available in that release. We have currently finished coding that, and I'm going through the tests at this time. And in addition to the model updates, we'll have our usual round of new features, functions, and changes to our own existing tools and templates. I want to thank you guys for being here. I am going to take a couple questions now as we have a couple minutes left, but I do want to thank you for spending some time with us to quickly go through these updates and better understand what kind of changes have been applied. Some of the questions that have come in right now, asking about background ozone units. Yes, the background ozone units can still support ppb, ppm, and micrograms per cubic meter. The change that was applied within 21.112 specifically addresses the source pathway background concentrations for the direct addition of backgrounds to the model output. So the background ozone remains unchanged. You can still have whatever units you would like for that. Was there an update to air surface as well? Not at this time. The version of air surface remains the 20.060 release that was made last year in 2020. The changes to the air screen model, I didn't directly address those here, but those were all bug fixes. So there were no major model formulation changes to the air screen model at all, just some minor internal updates. We will also be including an update to our air screen view software as we work on these AERMOD view updates. For our parallelized release AERMOD MPI, yes, it will still apply for 8 processors for all users of the AERMOD View software application. If you have needs beyond 8 processors, you can contact us, our sales team, sales@weblakes.com. We'll be happy to share information with you on getting a version that runs with additional cores. We also have our cloud-based run service that we can provide to you as well. What about background concentrations for VOC or HAPS? Can those be ppb, ppm, or microgram per cubic meter? Those can only be microgram per cubic meter. Again, on the source pathway, when you're dealing with those background concentrations, those are additive values to the model output. So those Other than NO2, SO2, and CO, anything else will have to be micrograms per cubic meter in this version of the model. If you have any technical questions, please feel free to shoot us an email, support@weblakes.com, and I'll be happy to take a look at that for you. If you have any questions about AERMOD View, purchasing that, maintenance inquiries, etc., our sales team would love to speak to you. So thank you again for being here with me. I hope you have a wonderful day and have a great rest of your week.